Thank you guys so much for being here. I know your time is valuable, but more, I'm actually afraid of being booed off stage, so I will keep the business, financial stuff very, very short. I just like to level set a little bit, because we do see some new faces here who have not heard about Infinio. Last time we talked to the Tech Field Day delegate crew. So the company was founded about 2 years ago. We've raised about $12 million today. Today, the company is just over 30 people. So we got a good sized team, but we're not a massive corporation or anything like that. Peter's going to talk to you a lot more about the product and the problem we solve. The thing I'll say is everything about Infinio is about being good to IT administrators. Our belief is that beyond everything, there's two things you guys care about: on time, on budget. So you're going to see that Infinio delivers a product and we solve a problem. It's a storage performance problem at the lowest possible price and with the absolute lowest burden on your time. And we're able to do that because we've geared our entire company around it. So anyone else who tells you they can sell a product as cheap as ours, and we announced our pricing today, Peter's going to talk more about it, they simply cannot. It's actually not possible to do it and have it make economic sense unless you've designed a business the way we have. Similarly, unless you've made the type of engineering investments we've made, you cannot actually try a storage performance product as easy as you can try Infinio. I'd argue there's almost no data center product you can try as easy as Infinio. It's truly a 30-minute POC, because all we care about is on time, on budget for you guys. So with that, I want to turn it over to Peter to talk about stuff you guys really care about, and I'm available for any and all questions. Thanks.
A lot of you already know what Infinio is, so if you could all take out your timers, I'm going to give you a 5-minute pitch, not 1 second longer. So here it is. Infinio is a NAS offload engine for VMware 4.1, 5.0, and 5.1. We support all supported VMware versions. Not 5.5 yet, but we just found out. We do this in software only. There is no hardware, no SSDs, nothing to procure. Just your existing ESX infrastructure. So the sorts of results that you can get, this right here is 15 VMs generating around 4,000 operations per second. It's a compile farm workload, 15 different versions of the Linux kernel, 2.6 to 3.0, all at different parts of the process of compilation. As you can see, average latency is around 40 milliseconds. This is pre-Infinio. At this point right here, Infinio installs, latency dramatically smooths out and drops precipitously down to around 10 milliseconds. The thing worth noting, though, is this right here. There wasn't an interruption in the workload. The workload kept going. It just got faster. And we can do this because of our architecture and because of our deployment packaging, which we'll get to in 2 seconds. As a result of the reduced latency, I don't need to explain this to you, we get more IOPS. Write latency also went down. We can move on. So how do we do this? We deploy a virtual appliance to each one of your ESX hosts, gets 8 gigs of memory, down to 4. We haven't yet tested to 16, so we don't go to 16 yet. We fully reserve that 8 gigs of DRAM. We also assign 2 vCPUs, but only reserve 1 of them. Our software takes all of that memory, and it pulls it together into a globally deduplicated single instance store that's visible to each ESX host. And that's key, because we aren't talking about having a silo of cache on each host. Every single host in your cluster sees 1 cache. If this VM here were to request content B at address 5, it would say to its neighbors, have you seen it? They would say no. Goes to the storage system, fetches it, brings it back to the cache. Now this VM over here, it says, I also need content B, but at address 2200. This guy here gets the request, and it says, hey neighbors, where's content B? This guy says, I just saw it a couple hours ago, sends it over, you don't go to the storage system. It is literally that simple. That is what our product is in a nutshell. So why don't I take 2 seconds before you know what, I'm on a timer, so let me get through this. The way you get it, you go to our website. We're totally internet go-to-market. You download our software. There's no steak dinners involved. This is just you download the software, you pay for it online. Today, we're actually going into public beta today. Tomorrow, you would be able to go and click the download button. It's a 40 meg installer, double-click executable, downloads in 20 seconds. Once you double-click it, you'll be brought to this, which has a video describing exactly what we do to your environment. Once you click the begin button and enter your vCenter credentials, it will scan your entire environment, do the validation, make sure you have sufficient resources, automated install, everything from deploying the OVAs to setting the reservations, setting auto boot order, shutdown priorities, all that takes care of the entire deployment for you. So you can deploy to one host or to your entire data center in basically, well, within reason, depends on how big your environment is, with 30 to 45 minutes. Once you're done with this, you can see on the left-hand side here, there's basically 6 steps. That's 6 next buttons. The only thing you need to give us is one IP address. Now think about that for 2 seconds. We've deployed an accelerator onto each one of the ESX hosts that has a data store you want to accelerate, yet you're only giving us one IP address. And the reason is because we know you hate IP address management, so we use linked local self-assigned and self-discovery of cluster nodes so that they can find each other, they can give themselves IP addresses that are not routable in your network, and form a caching layer. So once you get out of this, you go back to the console here, and this is, I don't have a lot of resolution here, but this is in our test and automation. This is actually one of our longevity test systems that's running some unknown workload. I'm not quite sure what it is. But what you can see here is, the offload rates are respectable. On the response time improvement, the back-end latency right now is 170 milliseconds, so it's kind of getting hammered a lot. And we drop it down to 12.2. That's the blended latency. So that's our latency plus cache miss latency, which is roughly a 14-time improvement in latency. If you want to look at historicals, you can look here. Yeah, you can see it went through a new test cycle there. Response time, requests offloaded, and bandwidth saved. Let's see. The next thing worth looking at is the left-hand side. So we've got sort of, to help you justify ROI, really. How many disks didn't you have to buy? That's really what it comes down to. Total system performance and dedupe efficiency. Simple as that. Now, the next step, you've already accelerated one of your data stores. That's what the installer does. It takes you straight through to acceleration. Now you want to accelerate your next data store. There's a list of blue buttons. You click it, you confirm, 15 seconds later, you're accelerated. There was never an interruption to your workload. It just keeps going, gets faster. Now, if by chance you think all of this is nonsense, we'll help you out. So it's kind of funny that a startup would invest to help you remove our software, but that is exactly what we did. That one button right there, you click it, in 5 minutes or less, we remove every trace of our software in your environment as if it had never been there. So it's almost like a challenge, right? Just give it a shot, try it on your workload. If it doesn't perform, get rid of it.
Eat toilet paper.
Yeah, yes. So that's really the whole pitch, and I think we should dive into any questions you have. Go as technical as you want, or we can talk about pricing all day.
No,
Colin? Oh, right. Pricing. $4.99 a socket.
$199 or $4.99?
We'll take what we can get, but it is $499.
Okay.
And that includes the first year of maintenance, of course.
And by the way, the company will stand back. We've not seen any pricing that is anywhere near that cheap, particularly when you account for the fact that our competitors require SSDs in most cases.
And how many nodes do you support in cluster?
A single cluster, the maximum size supported by VMware.
Okay. And do you need 10 gigabits or?
Nope. So one of our deployments is a 12-node cluster. 4 of the nodes are 10 gig. The rest of them are 1 gig. So you can actually have asymmetry.
Okay, but then how you can manage all the difference in latencies or bandwidth?
We amortize all of the requests across the entire cluster. So no single point becomes a choke point. So imagine what happens when you have a siloed cache approach, right?
Mm-hmm.
Just because it will make it a lot easier for me to point at something. So let's pretend this is a siloed cache approach, which we are not. This is a VDI machine. It's got 200 VMs on it with a local cache. You put that host into maintenance mode. All of the VMs evacuate to other hosts. Now, if you've got a siloed approach, you've got two options. Well, you've got three options, but we'll only talk about two of them. One option is you could go cold cache on all the VMs once they go to their other hosts. Or, when they get to their other host, they could call back to the originating host and say, hey, give me your data, right? So if that were to happen, if you were to put 200 VMs and do a maintenance operation, and they all move, and they scatter and say, hey, host, give me all your cache data, that single host is the point of contention that would bog down performance for the VMs. Our approach is to amortize across the entire cluster, so no single host becomes a point of contention.
So a couple questions
Yep.
about, I guess, overall architecture, and then that statement about amortizing blocks across your cluster.
Mm-hmm.
So one, is just to echo back, I heard that you're saying this is an in-memory NFS cache.
Yep, correct.
With transparent insertion and removal.
Uh-huh.
No
No ACL changes, literally transparent, not a single change to your network, ESX host, or storage system.
They're using non-RC 1918 compliant addresses to provide a
Yep.
communication channel between your
Yep.
between your caches.
Overlay network on the vMotion network or other VM kernel interfaces that are consistently applied across a cluster.
Okay.
Yep.
Without, so you have the option of not having to configure a separate network, but
Uh-huh.
the ability to support that. Let me see. Got those
Are those
questions.
choosable or automatic?
Today it's automatic.
Yeah. So it's in memory right now, and there's a lot of new technologies coming out from Intel. We've already seen some of the production samples out in the market with NVMe. Basically have DRAM, supported PRAM and memory resistor in the middle, and then large amounts of flash that are addressed in one config register. Have you guys done any testing or have any releases in the future that allow for the segregation of workloads across those tiers?
Not today. No, and we have not done the testing.
Okay.
That's a good point, though.
Excuse me, the NFS is a limitation because
We operate at the protocol level. So 12 months ago, we got our Series A. We brought a product to market in 12 months, and we could only support one protocol with this level of insertion. And that was our real focus, is to make it as simple to try and buy. So having to do reboots, having to do plugins, that was, for me at least, that was a non-starter. We chose NFS because I won't say it does, but it has the reputation for having the worst performance.
Are you working on other options for that?
We are. I'm not quite sure whether it's going to be fiber channel or iSCSI. We have three approaches. One of them
over token ring?
Not over token ring. That'll be version 3. How about that? So one of the approaches would give us the seamless insertion, but limit us to software iSCSI only. The other approaches would have a compromise of either A, requiring data migration, or B, requiring a reboot. And my feeling right now is that we maintain the core principles of the company, which is easy to try, easy to buy.
Makes sense.
What about something like, say, CIFS or SMB?
If we were to go to Hyper-V,
let's
we
call
would
it then ODX instead of SMB.
we would certainly consider it. But right now it is VMware only.
Okay.
A lot of the cost of the company goes into platform integration. If only there were a standardized way of interfacing with every one of them.
They do. It's called OpenStack.
Wow.
So I wasn't here I wasn't here the first time, but so when you vMotion a VM to a different host, that cache isn't automatically on that. It's got to go pull it from somewhere
It doesn't-
else, right?
Not for us.
No.
No. So so there's two layers of translation: address to digest, digest to content. So our address to digest is pushed into the distributed grid,
Okay.
so that when this VM goes from here to here,
Right.
this guy, literally what it does is it sees an initial request for a file handle. It checks the WCC data that's provided by NFS, and it says, oh, I haven't seen this before. It then takes the WCC data and asks the cluster, who's got all the stuff for this WCC and this offset? Cluster says it's over there. He grabs that mapping table, and then he's off to the races. There was no content. There was no actual content being moved.
So he, being the client, is then directed into, say, I'm on host A, data's on host C. I'm direct, so I make a call. My local, my closest NAS proxy, for lack of a better term, identifies that cache data is not local to me, and communicates back to me to then make a call across the network to the far side cache.
For mapping information only.
So what
For mapping,
happens
but-
when that host goes down?
Which one? The one that
where
it
the
transferred
data
from?
was. Yeah.
It's only 1/nth of the content. It doesn't mean that all of the content for that VM was lost.
So it could just be, I don't know. host
It depends on
down.
the placement. So the placement is sort of opportunistic. So
You're storing.
But it is possible that it won't be there.
there is a chance that if this host were to go down at the exact moment of failure, that you could potentially lose every cache block for the VM that was over there. But there's no guarantee that all of those blocks live there.
But at that time, you'd basically push a fault back up to the client,
exactly.
which then retry, and your caches
The
would
client-
know that you just do a read through.
The client would never know that anything happened. It would all be this system right here would take care of all of that.
Okay, so you don't actually pass a fault back up to
Nope.
the client.
The client is
you observe that coming back from
completely
whatever was
unaware.
proxied.
Completely unaware.
What about network contention? So there's a lot of obviously processors get faster and faster every day. Flash is becoming relatively ubiquitous. There's some announcements going on this week around NSX, and it's all about overlays right now. But a lot of the research in that space is around very finite control of flows, and you get a lot of information back out of the network infrastructure. Are you guys measuring for contention in links, either passively, so by observing latency,
Yes.
or actively?
Absolutely. So every single operation that this system does is asynchronous.
Okay.
If this host were to get, let me just back it up actually. The philosophy that it all comes from is think globally, act locally. If I'm a member here and I've got these other members, right? If I see you and we can talk to each other, we'll moderate, we'll play with each other nicely. But if one of these guys goes away, then let's say it was a network isolation problem, right? So you get loss of connectivity between hosts. All of these hosts would say, well, I can't see my peers anymore, so I'm going to start acting locally. And I'm going to try and reach my peers. If they're available globally, we'll start talking together. But what happens when this host over here has network contention problems and this guy's trying to push content there or pull content?
Yeah.
And the answer is there's just very granular timeouts. And if you trip the timeout, we say ignore this host until it drops below a certain threshold.
So when you do experience network congestion, it flips
We
through
back off.
into just a write-through cache, or read-through cache.
Well, no, because again, it doesn't mean that this host has all of the content that's necessary for everything over here. We're placing content throughout the entire cluster.
No, I understand
So
that,
you
but-
would lose some, like in this case, you would lose 1/nth of the entire cache.
Well, I guess my point on this, you're not losing the data; it's still on the NAS
Yep,
behind it.
yep,
You're supposed to
precisely.
acceleration of
Because
that
it just
data.
lets the caching, the
And
benefit of the caching.
I guess the question, I know when we saw 10 gig first came out, right? There was a whole bunch of before quality of service became the best practice for inside of VMware. There was a whole when people were not putting quality of service and segregation on shared links. So you'd see a lot of these issues where you trigger a vMotion that would cause a fault within the the NAS access, which then trigger DRS. Basically, get these feedback loops that occur in your infrastructure. I was trying to, I guess the question I was going after is, one, how is it measured by your cache? If you are equally distributing blocks or portions of the data through an entire cluster, there's a possibility of creating that. And I was curious how your software measures that effect happening within itself, within the cluster as a whole, and what steps do you do to mitigate that?
And it's really all about the whole act locally, think globally. If I'm asking somebody for something or I'm giving something to somebody and they are not responsive in whatever I consider responsive, I say, we're not playing together anymore. Otherwise, the rest of the cluster, we can all play together nicely, but you're in timeout now, which effectively means that that host is going to have diminished load on it because its neighbors are going to start ignoring it as a result of it having contention, which says, let's say I'm the first one here to say this one is in contention. I stop talking to it. Does the performance increase sufficiently that this one doesn't ignore it? If not, then this one's going to say ignore it. And it's just this host is effectively going to be isolated by virtue of the fact that all of my buddies stop talking to me.
Is there any metrics that you push up through the dashboard?
No. The dashboard is 100% about what value we deliver. It is not an operations tool. It's not a diagnostic tool for diagnosing your storage system. It is purely to show you what value you got out of our software.
Then how do you operate and manage it?
That's the whole point, is that you don't need to.
It manages it.
So one thing I'll add is in our early trials, this is actually something we were quite concerned about too early on, is what about the network contention issue? It's actually been a much smaller problem than we thought. As we've gone through the early trials, and it goes back to a lot of what Peter's saying, where you're distributing load almost evenly, right? So yes, you are creating network traffic. There's no way to escape it. And yes, you can hit contention issues, in which case we start to back off. But generally speaking, it's no one. You're using a lot of pipes that are underutilized most of the time. It's on the rec band.
That's an assumption.
It's absolutely an assumption, which is why there's a backup.
Okay. I'm just curious what metrics you're exposing, so you don't have to operate based on assumptions. You can operate on science.
Yeah, there are no metrics presented around, publicly presented.
Along those same lines, like if your data lies on another host, I mean, why is that better than if you're going over like a 1 gig network connection? Why is that better than like a fiber channel connection to a SAN? You know.
Well, I don't know that it's better or worse. It's just different. I mean, really what we're trying to do is offload from this, right? So, sure, we might be burning some east-west bandwidth, but the point is how can we offload the most number of requests from the storage system?
Okay.
We're saying, can we leverage some of these cheap resources up here, the most commoditized tier of your infrastructure, right? Can we take some of these resources, whether it's network bandwidth, memory, or otherwise, string it all together so that the most expensive part of your infrastructure isn't getting as taxed?
But your slide about performance indicates that it's really more about performance,
It's not
right?
about the network difference between the servers or between fiber channel. It's about the fact that you're not running it from disks.
Yeah.
That's the difference.
Yeah.
It's
So you're not
not, it's
gonna
not
pay
about the
a bunch of
network
money to
difference.
see.
It's about it doesn't come from disk. It comes from within the servers.
The point about performance.
If that 1 gig bandwidth is available, transferring 4K over a 1 gig link is a lot faster than a head seek.
Okay.
The,
Now, when that 1 gig becomes overloaded, we, ultimately, their timeouts have to be somewhere in the 1 to 5 millisecond range, so that they go, well, getting this from the cache is going to be slower than getting it from the disk, so we might as well get it from the disk.
The point about performance, though, we show that to show you relative performance.
Okay.
What the performance of the data store was before and after. Not to say that, like, we aren't claiming that we're going to make all of your accesses 2 milliseconds, because we're really just blending the latencies of extremely low latency with something that's probably a little bit higher on the back end. And by the way, we heard you loud and clear, and there is 0 modeling, and that's Howard. And then Mr. Novak suggested that we ditch.
Oh, the button?
The brag bar.
Yeah. So
Braggy.
actually, the brag bar has a name. It's an anti-feature name called the No Brag after Mr. Novak. And so it does not exist. It's gone.
Thank you.
Look how much power you have. Great responsibility.
Yeah.
So in your cache cloud,
Uh-huh.
you have, let's say, 10 nodes.
Mm-hmm.
Do the nodes themselves know their place within the cloud? Say that it's a linear network and you have hosts, so far away, and there's different latencies between them. Does the node in the middle know that the adjacent ones are adjacent versus the far ones?
We do not do topology discovery yet.
What's the biggest cache cloud node you've played with?
We did a 14 nodes. All of them are, so in that case we actually did go beyond 8 gigs of memory, but still it was just limited to a subset of the maximum cluster size. But we know how the algorithm works as far as scale beyond, the thing you need to consider, though, is that we limit that scale to the size of a single cluster. So no cluster will talk to another cluster. This is another assumption we make, which is that you set up your cluster topologies the way you did for a reason. You set up a DMZ because it's in a DMZ, and you set up the one that's labeled production someplace else. So we shouldn't be passing data between them because we don't know if that has some security boundary or otherwise. So we will only install and we will only communicate amongst our nodes in a single cluster. You would have to install basically a separate instance.
Sure.
And that's not to say a separate management tool, just the accelerators themselves.
And there's no data locality that any given chunk belonging to any given VM can be on any given host.
It can, yes.
Okay. And you're only keeping one copy of every chunk, right?
One copy. Yep.
Across the cache.
The entire
Right.
cache.
Yeah, well,
yep.
it's a write-through cache.
Yeah, within the
We don't
cluster.
I mean,
yep.
across the multiple nodes.
Yeah, but it's a write-through cache, so we don't have to worry about,
Yep.
if the server goes down, what happens to my data, because it's just a copy.
Mhm.
Yeah.
So
Almost like acceleration for NFS.
Yeah.
Almost.
a couple questions on my side.
Yeah.
One, are you doing any deduplication of data in your caching tier? And two, let's please not use the word cloud. Just because there's more than one thing and happens to run somewhere else does not make it a cloud. wasn't at you.
So our cloud solution, no, I'm just kidding.
I'll hold him back.
Yeah.
So there
Deduplication.
is no compression. There is deduplication in the form of single instance storage.
Okay, so you do single
Yeah.
instance storage.
And
of
it's not
files.
persisted to disk, so we don't change the format of data on disk.
Okay. Do you have any? So you're exposing metrics about IOs.
Mhm.
I know some
Yeah,
of-
we do. Let me show you.
You expose deduplication
Yep.
statistics.
Yep. 1 sec.
So what's the deduplication granularity, Peter?
4K aligned with NetApp. That's sort of the.
Okay.
People who
So-
do NASs for a
so-
while.
so
yeah, yeah, exactly.
Okay, so that's really deduplication, not single instance. Yes.
No, it is deduplication.
When we hear single instance
Yep.
storage, we're thinking file level,
Yeah.
not.
Yeah. Yep.
So it's dedup.
That's better.
I was referring to it as that because of the acronym ASIS, but it.
Oh, yes. They gave that up a long time.
Yeah. No, I know. Yeah. So there is a metric there. Yep.
So you're doing inline deduplication of NFS storage in a distributed fashion across up to a 14-node pool.
Up to whatever the maximum cluster size is supported by VMware, which I believe today is like 26. I'm sure somebody knows that it's a different number.
I see a couple of VCDXs here. Can you confirm that?
32? Okay. There you go. Ding!
In this room thing, someone would know the answer to that question.
I have a quick question about the fact that today you are proposing the solution for accelerating NFS repositories. But also today, VMware
Mhm.
has launched the vSAN and many others are working
Yeah,
in
sure.
VSAs and so on. So potentially your solution has a limited time. Has limited time.
Well, Microsoft also had NT backup.
I think to qualify that question, what is your unfair advantage in that space?
My question is, okay, you have a limited space for working because the new infrastructure potentially will be designed on more and more on software solution like VSAs
Mhm.
or mechanics like or whatever.
Well, some
Hey.
of which present their data via NFS as well.
Yeah, so
but
so
then
SimpliVity and
it's
Nutanix both present
very-
as NFS.
Very complex to manage the NFS split on all the nodes, and on top of that, caching system on all the nodes and so on. So
Mhm.
it's not very efficient, at least.
The other thing to think about is that just because they've announced vSAN doesn't mean everybody's going to replace what they've got with it.
Yeah.
And there are
No,
going to
for
be
sure.
people using NFS in huge
Yeah.
volumes with huge sensitivity to latency and performance for at least 3 or 4 weeks. So, you know,
what do you think the current market share is for ESX 4.1?
Pretty significant.
It's
45,
50%.
VMware does not do a good job at install-based management. mainly
Yeah.
because they charge out the hoo-ha for licenses.
Yeah, and speaking
Well,
of licenses,
people still run Windows 2003.
yeah,
so,
yeah.
You know,
Yeah.
there is inertia in the data center.
Speaking of licenses, so those products you were referring to, specifically the VMware ones, even today we got our first glimpse into them being Enterprise Plus licenses to even access them.
Yeah.
And if you look at a solution like this, it's pretty squarely targeting the mid-market. And quite frankly, I haven't seen a lot of mid-market companies that are diving into E+ licensing.
I agree. And the question I had is, and I think it was based on that question. So, this is becoming a busy space, and VMware has consistently demonstrated, as I identify entrance into a market, people are making money off a feature, they roll it into their goal, or they roll it into their higher end licenses. What is your unfair advantage? So, what are you doing in this market that clearly and concisely protects you from other people encroaching on your business? Or that differentiates you from the other entrants in this caching tier software?
Yep. Zero hardware. No additional hardware. That's a pretty significant difference. And everybody is riding this wave of Flash. And it's not to say that someday we won't introduce support for Flash, but my position is that the right amount of cache is what you need, not more cache. And we can give you the right amount of cache for the majority of workloads in the market that we target. And we can do that without any hardware, without really any hassle.
That's fair.
What's the cost of an 8 gig DIMM? $40? So,
Yeah, it's pretty cheap.
So I will.
ECC registered?
Yeah,
Well, in big servers, I mean, 8's kind of small. People are usually buying 16.
right. So
Not
you
much.
say no hardware, but it's really one more DIMM.
Yeah, there's also some really interesting stats available.
Well,
About-
it's, if you don't, you're going to consume the memory that would constitute one more DIMM. So it's kind of like if you're doing the pricing model, you just figure another DIMM.
Yeah, that's a valid model. Valid technology.
Yeah. So there's some interesting metrics published about average memory utilization, and it hovers somewhere around 60%. So as far as we can see, there's a lot of latent resources to be leveraged.
Yeah.
And especially when you compare, the cost of those resources in the server tier relative to the cost in the storage tier.
Oh yeah.
There's
totally agree with you. Yeah, my question was, is what's protecting? I think I'm really interested in some of, really neat what you have here. What's some of the future releases? What are the hardest problems that you're trying to solve right now?
We could talk about future releases if there was.
Going
As
back to
Steven
Rob's
moves
earlier
Or
question.
what are the bigger problems that you see need to be solved that you feel that?
I mean, I'd love
architecture-
to share some of that, but
If you can't
I'll leave it to him to.
Well, I don't think we should go too much into future releases right now. Maybe another time.
That's fair. And do anything about the problem? What do you think is the largest unsolved problem in the industry?
I mean, I'd give you my take. I actually do think this is a really big problem. I really do. And I think part of the unfair advantage, and certainly, Peter or anyone else can feel free to jump this. The problem is just, this is about utilization, like we've talked about, right? This is partially about acceleration, but this is largely about helping you use your storage better. And I think all these solutions, things like vFlash, they're going to do that too, but a lot of what they're trying to do is about the microsecond I/O speed up. And I think the idea that you can help people use less storage and do it by pooling resources at the cheapest tier, that's never going to go away. And so I don't actually think of vFlash, I don't think of some of the other competitors like Pernix Data. I don't even really think of us as the same business as them. I think it's like a subtle nuance. But I actually think we can expand this to other block storage devices and build a really, really big, really sustainable business. And on the pricing, I don't think anyone can touch us. If you want to build a company that can sell at this price point, it's not just about the product. It's about everything. It's about how you operate. It's about your sales model, your distribution strategy. And so I think if you can always help people utilize existing resources better, and again, back to the question about vSAN, the storage industry right now is, almost an order of magnitude bigger than the virtualization industry. It's going to take a long time. I'm not just talking about the legacy stuff out there. It's every day EMC and NetApp are selling tons of arrays. And if you can make the utilization of those better, I mean, you're going to have a big, big company.
Question. So, how do you actually insert are you transparently inserting on the network layer for your NFS, or are you actually pushing back into the vSphere APIs to transparently insert that?
So there is vSphere API integration, but not at the kernel. It's all through vCenter actually.
As far as vCenter. So you're basically putting a
I can
yeah, if you draw.
Please do.
Draw that.
Yes.
draw that.
Colin will like this.
Well, no, the reason I'm asking is because there's a lot, especially on like chipset design clusters, you get out past 6,000 nodes, you end up with these scaling boundaries inside of inside of the parallel compute that you end up having to put NFS caching down with all these dirty little tricks. And being able to transparently insert a caching layer dynamically in certain areas, like compute pods, normally like 500 to 600 computers. It's actually kind of neat.
So I'll go over what the before and after picture looks like. So before, ignore everything right here. You've got your data store. The data store, we look at the address to determine what VM kernel interface is being used to access the storage system.
Okay.
We look at the VLAN ID of that VM kernel interface. Right now it's 2, let's say. We then look at your entire environment and we say what VLAN IDs aren't you using. So let's just pretend and say since 4095 is off limits, 4094. So we would create a private VM port group, 4094, with a VNIC here, appropriately named and labeled. Then here, we would actually create a public VM port group, VLAN 2. We would match the NIC teaming policy from the VMNIC to the public, and match the VMK's NIC teaming policy to the private side.
So transparently inserting.
Well, the next thing is that we now that we have all of this plumbing set up, all we do, it's as simple as this. 4094. You flip that, and traffic then just flows straight through us. We do it in an IP forward mode.
Okay.
So it passes through us without modification.
So you're bumping the wire, observing the frame at that point.
Exactly.
Looking at the file identifier within that frame.
Exactly.
And then transparently redirecting it out of local cache.
Yep.
Do you actually wait for that request and reply to come back from the array and substitute? Actually, no.
We look at responses from the array and
Okay.
put that into our cache, as well as looking at write content to
So
seed the cache as well.
You reply with the request, but then you're looking
Yep.
for a reply back from the array where that file wasn't found or something.
So
Just curious.
we wouldn't even send it to the array. We would actually withhold the request if it's something that we knew we had in our cache.
So you make an assumption that a delete operation
Only if
was
it's something that we didn't.
communicated
Only if it's something we knew we didn't have in the cache.
across. Okay, so say a file was deleted, someone else had access to that data store, deleted the file, and but you make the assumption that all of your caches have visibility to file operations.
Oh,
from
you're
the
saying
data store.
deleted something, meaning something from the file or
Yeah.
directly offline? That's where WCC data comes in.
Okay.
So WCC data is the thing that allows NFS to be cluster consistent.
Okay.
So you look at the timestamps of the WCC data and you compare it to the last known of the last request you saw. So every single request that passes through the cache is tagged with this value. And you're constantly just comparing the two, saying, is this an order? You could almost think of it as a sequence number, but it's not sequential. And that's exactly what allows us to say, has a file been deleted from the disk? Because we'll see attribute updates, we'll see all of this stuff.
Okay.
And that is literally how it works. So the change in your environment that you would see is the addition of 2 VM port groups, one with a private VLAN and one with the previously known public VLAN.
Okay.
And then the VM kernel interface that was already there, you would just see a VLAN change, nothing else.
So,
How would that work in like a Cisco 1000 environment?
So are you talking like a distributed vSwitch type setup?
Well, not really. I mean, Cisco 1000V, all of your networking, your switch is controlled through the Cisco 1000V.
separate VM kernel or
Yep.
separate network kernel.
I'll have to look into that. I'm not sure if they do a translation from the vSphere API into the 1000V.
No.
So you can't modify a VLAN ID of a. Okay. Well,
Normally you would do it from 1000V, then it pushes it inside of VMware.
we can add that to the list of unsupported environments.
Yeah, basically,
But not a lot of
That would be the
1,000
express-
people
Yeah.
in the SX market.
mid-market's all you do.
Yeah, maybe it's worth
If
looking
you've
into.
got a Cisco UCS implementation, there's a chance that you have 1000V.
An NUV block test.
Yeah, I'll check it out.
That's kind of so.
It might work out of the box for all I know. We'll have to put it through its paces.
And so what you do, so you have basically using APIs to automate the configuration and insertion of your
exactly
transparent cache. But fundamentally, that is, and I'm making the assumption here, is what I'm hearing is you're automating, you're consuming or contacting the APIs to automate the plumbing action. But besides that, once your transparent cache is inserted in the flow, it'll accelerate whatever it sees going over it. Is that an accurate statement?
Yeah, it's effectively a network device at that point.
Okay.
Transparent proxy.
Have you tried just transparent insertion of that cache in any other modes?
What do you mean other modes?
And I'm coming right back to the parallel compute cluster. So like, there's a lot of clusters that have instances that may have KVM inside of it. That's, there's ways of basically putting a VM or putting an instance with let's call it, putting an instance with interfaces on different segments, or of routing flows using different networking technologies through a cache. Are you able to instand? You just in purely theoretical or pure experimentation?
So we've actually mucked around with some of this for render farms and for, I don't remember the acronym. It's EDS, Electronic Design Systems.
EDA, Electronic Design Architectures. That's the chipset design clusters. Then you also have what's called oil visualization is another set of workflows that share these same problem set.
Yeah, so to really just directly answer your question, there is absolutely no reason you can't point other things through our accelerator.
Have you guys even started to experiment? Like NEC actually has some really good examples of this, and there's Open Daylight for flow controllers. Have you guys even just kind of noodled in the mind, and you can see NSX going this direction, of using transparent flow control to actually steer flows through your cache? That would break you away from your VMware dependency.
Yeah, we could look into something like that.
Just me being crazy.
I think the process we do, it would work with Xen. It would work with KVM. There's, as long as you're TCP compliant, which of course they all are, there's really no reason you can't do it.
Don't make that assumption. STT is not TCP compliant.
Well, the markets we would likely get into, to the best of my knowledge,
That's a
are
better way of putting it.
compliant.
That's really interesting. Kind of got me noodling on something. That's really neat.
That's a compliment when he noodles on you.
How do you learn about, so in the learning mechanism about pure caches, like how do you have like a localization ID that says I'm participating in this cluster? Are you looking for L2 adjacency? Is multicast goes out?
It's the console's role.
The console, so there's a management orchestration.
So today it's the console assigns membership.
Okay.
Tomorrow, I don't think this is so special that I can't share it. Tomorrow we're actually going to layer MDNS with group identifiers, GUIDs, that would basically allow them to self-assemble based on the MDNS broadcasts. So you wouldn't actually even need to assign them. They would just, can we talk to each other? Are you part of the same group ID? If so, let's figure out where content should go, and the console doesn't need to be involved.
Pretty novel.
Thanks.
Cool.
Is it supported with SIOC enabled on the news?
It is, yeah. Yep.
No, it doesn't affect the, your results.
The reason we can do it is because one thing I didn't mention is that on the VM kernel interface here, we modify the NIC teaming policy and set the NIC to disabled, which forces the connection into the vSwitch, going over the VLAN that we just set up, the private VLAN. And you would enable SIOC for presentation of the interfaces into the appliance itself.
Do you care about MTU size?
We handle it. So you would actually, let's say you go into the VMK and you modify the MTU, we would detect the change and update the MTU on our public and private interfaces on a per VLAN basis.
You mentioned about load balance mechanisms, and do you care if somebody's doing an LACP channel versus X channel?
We don't even get involved. We don't need to be. Whatever you set up as your policies on your vSwitch that was either explicitly inherited, or let's say you had a differentiated policy on your VMK, we just take whatever you had and we apply it to ourselves. That is one place where we don't automatically detect changes. So after you install us if you were to go in there and change those teaming policies, we would trip up. But the reason we do that, and we didn't spend so much time handling this whole reconciliation process, is because I think we have a pretty valuable asset in that we can insert and remove ourselves without disruption. So if you were really going to do maintenance, then the process is you disable acceleration, make whatever changes you want, and click the button, and a few seconds later, it's back in business. And we're going to rely on that for stuff like upgrades, for instance. So upgrades are going to be a rolling upgrade where we just take down one node. The field replaceable unit is literally the accelerator VM. We just rip the VM out and replace it with the latest version. There's no reason to go into the accelerators and replace packages and components. That just gives opportunity for problems. So we just replace the whole thing because we can. No reboots, no disruption.
I'm just noodling even within NSX. Sorry, I'm really hung up on this. Is that, oh no, because so it announced NSX today, which is the worst kept secret in the world. And so a part of that is a multi-hypervisor. So you could actually take your VMware integrations if you integrated it. So if you look at what they're doing with like the virtualization layer inside NSX, they're taking network virtualized functions and aggregating them inside of basically a services node and allowing a whole bunch of hypervisors to access to it. You could use it to transparently insert. I'm not sure what the way the overlays are set up now. You could also do the same thing with OpenFlow and OVS. Just put a match to the NFS traffic and have it transparently redirect through your cache.
We were actually
different hypervisors, lickety split.
When I was originally researching the approaches we could take for doing this, we were looking at similar techniques for redirecting content. None of them were quite as good as this, which is why we didn't go. But like WCCP, stuff like that. Certainly mechanisms that you can use for redirecting content. But at the end of the day, we just went with the simplest approach, and this was it.
Sorry, I was noodling on solving very specific problems that scale out.
Yeah, we should chat after.
Yeah. Any
other questions?
By the way, the Nexus is free to play recently, so you can
cool.
play with integration.
Great.
Oh, the V1000.
We will get on that.
As long as you have Enterprise Plus.
Well, yeah, that's the VMware requirement.
Mm.